Excellent. So good afternoon, everyone. Thanks for attending. My name is James Gress. I am the Accenture ATC Tampa Cloud Infrastructure Engineering Lead and Capability Lead. We put this meetup together to share all things DevOps and to see the very latest in the space. We're always looking for good speakers, so if you're interested, please drop me a note and we'll see what we can do about getting you a spot. We have the DevOps Days 2022 coming up in October 21st. It will be an in-person event. It's looking very promising that everything's going to go really smooth and be able to actually pull off that in-person event. We're always looking for organizers and volunteers and help there. So if you're interested in being part of the DevOps Days 2022, drop me a line. This will be a recorded event and posted on YouTube. So some quick guidelines for the call. Please stay on mute unless asking a question to help reduce any unnecessary background noise. We encourage video as it helps it make it feel more socially engaging. At the end, we'll open it up for some questions. So please keep a note of them or ask them in the chat window. Ravi has also mentioned during his presentation, if you do have a question, please feel free to come off and mute and go ahead and ask. We'll keep it as a very open dialogue and more of a discussion. So for today's session, Ravi at Northwestern Mutual, a Senior Director of Engineering, will be talking about automating security compliance at scale and Northwestern's Mutual DevOps journey. So Ravi, if you want to take it away.
I'll share my screen. Can you guys see my screen okay?
We can.
Okay. Okay, guys, thanks for joining. Especially want to thank James and Tampa Bay DevOps, right, for giving me this opportunity, getting this group together to discuss some ideas here, right? My name is Ravi Devaneni. I'm from Northwestern Mutual. My topic for today is basically automating security and compliance at scale. I work on a team called DevOps Engineering at Northwestern Mutual. Our job is to basically create tools and processes for CI/CD and to enable DevOps, right? Tools that basically enable development teams to ship applications faster and in a more secure way. So I've done some presentations on similar topics at some conferences before. So this is definitely a smaller group. So hoping to keep it a little bit more informal. So like James was saying, please interrupt if you need to, so we can have some questions. But we can do a quick Q&A at the end too. But I'm interested in hearing some other experiences and stories as well. A little bit about our company here. Northwestern Mutual is a financial services company headquartered in Milwaukee, Wisconsin. We have locations in New York City, Minneapolis, no presence in Florida yet, but hey, I'm here, right? And I'm working remotely and we're hiring a lot of remote people nowadays. Fortune 90, America's best employers for women, diversity, veteran friendly, LGBT friendly, and you can see the theme there. It's a very inclusive workspace. In addition to all of that, we're working on some amazing, technologies in cloud and DevOps and some very challenging problems that we're working on, trying to bring a digital transformation to a 160-year-old company. So it's a good challenge to have. So we'll talk about CI/CD pipelines, right? What it is, like what do we mean by securing a CI/CD pipeline? And we'll talk about concepts of software supply chain security here and embedding security controls in the pipeline, right? And some of the tools that we have developed over the last couple of years to ensure that we're automating and enforcing these security controls. And like I said, we'll do a Q&A at the end. Okay, hopefully everyone knows what a CI/CD pipeline is, but I'll quickly summarize here. So remember in the old days, right, many years ago, we used to do waterfall development. When we used to do coding, testing, we used to deploy to staging, and then there was a user acceptance testing. And on a weekend, this was all released to production. It was a very major event, right? People working late hours and all of that. This was a lot of manual effort for sure. Replacing all of this with automation is essentially what CI/CD pipeline is, right? Obviously, there are a lot of benefits of doing this. You're releasing changes, smaller changes and changes in smaller increments, basically. As a result, there is faster feedback, right? There is reduced number of manual errors because most of the things are automated. And since a lot of testing and your deployment functions are automated too. And you're obviously releasing to market faster. And as a result, there is higher customer satisfaction, right? And this is an interesting slide, right? This is the number of CVEs we discover. This is public information discovered every year. You can see here that there is an uptick in the number of vulnerabilities discovered in the last 4 to 5 years. You can see 17,000 in 2019 and 18,000 in 2020 and over 20,000 in 2021. So 20,000 vulnerabilities, 365 days, that averages to about 55 vulnerabilities discovered every day, right? This is 55 new vulnerabilities discovered every single day. What this means is that there are more ways in which applications can be exploited, basically. These are known ways of exploiting, right? There are a lot of unknown ways which are yet to be discovered, right? Obviously, as a result of this, a lot more companies are focused on designing applications with security in mind, right? And this is another example. This is a very useful tool called Sugar. It is used to find, public secrets and sensitive files across GitHub in real time, basically. So you can see a lot of secrets are being committed to public GitHub, and I have run the scan for like 2 minutes. And if I leave it, it'll be a lot longer. So there's Google Cloud keys, AWS keys, private keys, usernames, passwords, database connection strings. These are essentially the keys to the kingdom, right? So if all of these keys are available to everybody, I mean, why would anybody need to hack, right? It's just right there. So the goal of CI/CD security is to find these issues as early as possible, because the later you find them, the more expensive it is to fix it. There is a study that IBM does every year, right? They have been following the study, and the cost keeps going up, which they say that the average cost of a single breach is $4.24 million, right? And this is the average across the world. And obviously in the US, it's a lot more expensive. As a matter of fact, US is the most expensive country for data breaches, right? Each data breach averaging over $8 million. And interestingly, the most common attack vector is, guess what? It is compromised credentials, right? Amounting to 20% of the data breaches. This is essentially developers committing credentials in plain text into Git, or keeping them in public EC2 instances or public S3 buckets and things like that. Obviously, no company is exempt. It doesn't matter who you are. Like if you do things like that, major companies have been breached: Equifax, Verizon, Facebook, Uber, Robinhood, U.S. government even, right? There's a lot of stories that happen. So we'll go into a couple of these security breaches and talk about like the reasons behind them, the story behind them, and then we'll see a theme there. Equifax breach, for example, this is, since I started following this, Equifax, it's a well-publicized case, right? 150 million people's personal data got exposed. Basically, that is, if you see a US typical presidential election, you get less number of votes than that, right? That basically means that this is every single adult in the United States. That's all of us, right? All of our data got exposed. Equifax had to pay $1.4 billion to get out of that, right? So why did this happen? The reason this happened was Equifax had a version of Apache Struts, 2.2 or version something, and they had a vulnerability, have the number there, that was discovered. This was back in 2017. And they never patched it, right? They never patched it. It was there. The vulnerability was there for anybody to exploit. And as a result, it did get exploited. Another one is SolarWinds, right? SolarWinds was one of those popular ones last year. What SolarWinds does is it sells a software called Orion. Orion is basically a network monitoring software, right? They have over 18,000 clients that use this software, including major companies like Microsoft, Intel, and like federal agencies like Department of Homeland Security and Treasury. All of their sensitive information, all such as emails and some personal data, got exposed. What happened there, right? A malware was inserted into this software, right? A malware. Basically, it's believed that they had their own, supply chain distribution system, and they basically routinely distribute updated versions of the software, right? A backdoor was inserted into Orion. When Orion's updates made their way into all these client servers, basically the hackers gained a lot of sensitive information about a lot of these clients, right? It cost SolarWinds over $90 million. Not just that, right? Now, each one of these 18,000 companies that use this software now must update their servers to clean up this malicious code because some of the data is already gone. And it is estimated that the cumulative cost for all of these companies to clean up could be over $100 billion. And obviously that's a lot of money, right? Not just these, like I mentioned, Facebook's, Uber's, these are, and Robinhood was all over the news recently because there was some social engineering attack that happened at Robinhood. Some customer service guy was duped into giving up all of the information of their customers, right? 5 million users, data was exposed, something like that. So this is a problem, right? So this is a major problem that we have to work on. So how do we do this? So this is a sample CI/CD pipeline that you can see several stages here, right? Idea planning, you have code, you have build, scan, all the way to deployment and post deployment, right? What happens here is when your application is built, your application is going through all of this. Your application is going through your source control, you're building your application, you're scanning your application through several aspects, you're having your integration tests, you're deploying. We need to ensure that there's a lot of tools in the pipeline, obviously, tools such as Checkmarks, SonarQube, Twistlock, right? And our application is going through a lot of security scans. We need to ensure that our security of the application is also is good, right? That our application itself doesn't have any vulnerabilities, right? By making sure all the security scans are in place. And not just that, right? This is a lot of tools, like I said, this is our supply chain. These tools have access to your application, your environment variables, data, business logic, and all of those things. If any of these tools get compromised, then we're in trouble too, right? The hackers just need one of these tools to get compromised, to insert a malware, kind of like what happened with SolarWinds. So making sure all of these tools themselves are secure is called essentially the security of your software supply chain. So obviously we have to secure all the tools used in the CI/CD pipeline, right? Some of the principles we use for doing that are principle of least privilege, essentially making sure that your tool has only the necessary permissions and resources to do the job it needs to do, nothing more, nothing less. Other things include things such as minimizing your attack surface, right? And hence the blast radius. You want to ensure all your communications are encrypted, things such as your operating system is secure, right? Some examples here, right? You want to ensure your repository settings are compliant, like merge requests, approvals are configured, right? Your default branch is protected. You have authentication and authorization implemented. SSO is implemented. Obviously, you want your company's data to be accessed through SSO, not through open access, right? You want to ensure people are using their company's email, right? S3 buckets are private and not public, right? You want to ensure that encryption at rest and in transit are all there, essentially. So how do you do all of this? This is a lot of things, right? Obviously, automation is the answer here, right? You want to ensure that you are trying to automate all of these solutions. And you also want to ensure, this is an example of something we've done. This is a basic rules engine, right? What it does is it checks for security configurations for all the tools that we saw earlier. And to ensure that we're following all the security principles that we were talking about earlier too. And it checks for any violations, right, on a daily basis, and it alerts the team when something is off. Obviously, some rules do fail, right? That means two things. That means that there is a gap in the system, or that means there is a problem that you need to address immediately, right? And then the team needs to do some extra work to harden the security of that tool or whatnot to make sure that doesn't happen again. Here's an example of the dashboard we created. This is all false data, but this is a great way, gives an idea of how there are certain gaps that we need to identify. Like here's an example where users email, right? There's a bunch of Gmail accounts, for example, right? And your Docker registry here is not encrypted, for example. So there's things like that you want to check on a daily basis. I'll pause here for a second for any question before we get into the next section.
So Robbie, there was a question in the chat, curious why there is no arrow from Artifact Restore to deployment and not the other way around. We keep it until later.
Yeah, so I mean, that was a diagram that I made myself, so it is not like completely accurate. So obviously you want your artifact to be stored, right? And you need to build once, right? And you have to ensure that the same artifact is getting deployed progressively through the environments, right? So the same artifact that you have built once is going to your integration, your staging, and then your production, right? So that's the idea. So it's maybe not represented in the diagram properly, but your point is totally valid, Dimitri.
Thank you. Yeah, my point actually was that when we draw those diagrams, it's like it's a projection of our thinking, and it makes sense to just draw those lines left to right as a sign of progress, but maybe that's also compromise our security thinking.
Sure. It's a valid point. Like here, so you see the artifact store, right? Artifact is created once, and then deployment happens from the artifact store. You're deploying it from the artifact store, right? You're not building it over and over again. And your deployment is happening to multiple environments also.
That's true. Thank you.
Any other thoughts, questions? Okay. So the next section here is we're going to talk about securing the application itself, right? Like how we can do it and some of the tools that we have created to create automated compliance. So there are two types of scanning here, right, broadly speaking, the static scanning and dynamic scanning. Static ones basically work with just your code, right? Just your code. Dynamic ones require your application to be up and running. So obviously static ones are easier to run, right? Because it's all there. But they don't always provide the best results. They give us a good indication. But the dynamic ones are hard to run because sometimes depending on the application, it is quite hard to set up, get it running, scan it, but definitely has the most accurate set of results, right? So let's start with static scanning, right? It means you're looking at the static aspects of your application here, which means your code, your dependencies, your operating system, right? Those things like let's start with the base layer, your operating system. This is your foundation, right? Containers obviously have grown in popularity in the recent years, right? We use a lot of base images that are available in the open source community. These base images contain a lot of vulnerabilities. They basically contain an entire operating system. There's a lot of components, libraries that we don't even know of, right? We are basically trusting these sources. Even images from well-known and trusted providers have had vulnerabilities in the past. So it's important to start good on a good foundation, right? OS scanning tools, some tools include Twistlock and Aqua Security, which I had in my diagram before. Next up, we'll have third-party dependencies, right? You need third-party libraries. Why? Because you don't want to write everything from scratch, right? Things such as authentication, for example, making HTTPS requests, for example. Those are things you don't want to create over and over again, right? There's a lot of open source libraries that do that job for you. So it makes your life easier. But it comes with a catch, right? These are open source, right? You don't have the time to review all the code that is in there. Like you don't know what you're getting, but you want to ensure that what you're getting is free of vulnerabilities. So there's tools such as Nexus IQ, JFrog, X-Ray, GitLab has their own set of tools, ByteSource can help with a lot of these, right? After that, we have our code on the top of that. This is the code that we write. We want to ensure that there are no vulnerabilities in the code like SQL injection and cross-site scripting and things like that, right? And then the code quality and code security are a little similar, but they're a little different too, right? Code that is easy to read is easy to maintain, right? And it is inherently secure as well. Like if the code is not readable, it's going to be harder for us to spot and fix these issues, right? There's a lot of tools out in the market, SonarQube and Checkmarks that address this aspect of security here. And dynamic scanning, like I said, is looking at the code, and obviously dependencies is one thing, right? Running your app is completely different. There's a lot of complexities that come with it. There's a lot of runtime variables, secrets, things like that. This is actually quite hard to test as a part of the CI. So we're not going to talk about this, but there are tools out in the market that do this. There's passive scanning, there's active scanning, there's some open source tools such as OWASP that are out there. that we can look into. So how do we do this, right? First, operating system vulnerabilities, right? We have to ensure that they're a part of our CI. So this is a sample GitLab CI template that it's just simple, right? Like we have a Docker image and we are basically running a script here. The scan image is that script that we're running. Simple, right? Next is dependency scanning here. Something similar, very similar, right? The difference is we are saving the artifact here for developers to look at and maybe some other analytic systems to parse through and report out, right? And same thing for your code analysis. You have a Docker image and you're running a script here, right? In your artifacts, basically the same thing. And probably you're seeing a pattern here, code quality scanning, also the same thing. Very similar template. That's a lot of things, right? This is already too much to keep track of. And there are things such as license scanning, other things that I haven't even mentioned, right? Obviously, this is a lot for a developer because a developer's job is to focus on their applications, right? All these checks that we are adding to the pipeline is just additional cognitive load that distracts them from delivering the features, delivering the business value. Plus, these tools are usually changing every few years, right? So there's constant rollout of new tools and new versions. Some versions, older versions are deprecated, and all the things that people have to deal with to maintain all of this. This is a lot of cognitive load. To reduce this cognitive load, what we can do is we can contain all of these checks in a single template, which makes it easier for all of these developers to contain all these security scans at once, right? But we can go a few steps further, right? We can even do things such as a single include template for everything, which basically means like everything you need to do to deploy your application. This is things such as building, your unit testing, your artifact storage, your signatures, your security scans, your deployment logic, your canary deployments, integration testing, all of those things can be a part of that template, right? So at that point, the developers, all they need to do is write their code, write their unit test, period. And all the deployment and everything else is then taken care of behind the scenes. So it's just an interesting thought exercise to see how far we can take this idea, right? Now, despite doing all of that, right? Like I talked about how there are new vulnerabilities that are getting discovered every single day, 55 new vulnerabilities every single day, right? So the application that is running on production that you think is secure today is not necessarily secure tomorrow. A new CVE is discovered that essentially makes it suddenly vulnerable, right? Like your app didn't really change, but a new way to exploit that app was discovered, rendering your app vulnerable immediately. So you need this idea of continuous security, right? So what we have done is essentially instituted a weekly scan that will report on basically all the production issues, all the production applications that are running, scanning all of them and reporting on those, right? Live reporting, right? Definitely it is something that people have to do, right? This is definitely because applications become suddenly vulnerable. Okay, so having all of these scans is nice, right? But what happens if nobody in the company uses them, right? That's a problem, right? We need to ensure that everybody in your company uses these scans. We need to ensure that all of these are present in all the pipelines. So we need a way to enforce these checks, right? So some of the tools that I'm going to talk about are pipeline enforcer and secrets detector. We'll go into them one by one. First, we have this tool called Pipeline Enforcer. It's just a simple rules engine, right? Which checks for existence of certain steps in the pipeline. That's all, like simple rules engine that checks for certain things. Things such as your container scanning, is that present in your pipeline? Is your code quality scanning, is that present? If those steps are missing, there are certain things that we can do, right? Like we can do things such as an automated email, right? It is sent to the committer. You can see the format, like you can customize this format based on your own needs. You can mark that commit as failed, right? That you're essentially blocking that commit from getting merged into your mainline. And at that point, you can choose to do many things, right? You can add a comment on that. So on that commit, so that information stays with the commit for future reviews, right? And you can even go extreme. If you want to go full enforce mode, you can do things like fail the pipeline, cancel the pipeline. If a certain security scan is not there, don't let the development team go ahead with any of those things, right? It really depends on the company. It's a business decision, obviously, that you want to make. So what's the secret sauce here, right? So there's nothing much. It's pipeline enforcer is just a simple file parsing. What happens is when a commit is made, we look at the diff and we look at the code and we look at the pipeline file that is creating that pipeline and ensure that simple parsing that is added as a webhook and ensure that certain steps are there. So it's not like really a secret. It's just simple Python parsing added as a webhook, essentially. Okay, so let me take a few questions here. Dimitri, you say that you have compliance procedures require a review of code changes heading to production. So probably a review of the third-party libraries is a must-have. Absolutely, right? But third-party libraries, if you have done Node development or Python development, there's hundreds of libraries that you're using in your code, and like everything has its own version. Now, who has the time to review all of that, right? That's a long process. So what we have, there is an inherent trust in the open source community, right? That these things are safe for teams to use. Like if you're depending on where you work, like financial services, there's a lot of data, health services, there's a lot of, emphasis on keeping the data secure. So this is a problem, right? Like you don't have time to review all the third-party libraries. Obviously you need to review your own code changes. With microservices present today in your applications, is it difficult to have an environment that would mirror production to test against for dynamic scanning? A good question, John. I think it is a challenge to recreate all of the complexity present in the environment, right? But obviously there are technologies that are available. There are tertiary deployments that, for example, that are there. Like you create your own branch, and that branch creates its own dynamic environment, a tertiary environment, essentially, which essentially mirrors in some way your production environment, right? And in theory, your application is running. So yes, I think dynamic scanning, a lot more options are opening up in terms of dynamic scanning as well. Great questions, guys. Okay, so I'll keep going here. So I mentioned earlier, right? Compromised credentials is the most common attack vector, amounting to 20% of all the data breaches that happen. So essentially, we said we don't want to give away our keys to the kingdom by having credentials in source code, essentially, right? Secrets Detector is a service that we have created in our team, basically, which looks at the commits, parses the change, and tries to find valid secrets, right? The key here is to ensure that the secrets are valid. And so this is basically a diagrammatic representation, right? The entire code change workflow, right, can be divided into two parts here, right? The blue and I think that other color is also blue, maybe teal, I don't know. The left part is developer local, right? The developer makes a change locally. The change is then stored locally, right? The next part is a push happens. The developer makes a push to the origin or the remote server. The change then gets to the repository and the change is made permanent, right? You can see 4 boxes underneath. These are interception points, right? So let's start from the rightmost. We have our post receive hook. This is after the changes have been made permanent. Now they're a part of Git history already, right? So once your secret makes it into Git history, it's a painful process to scrub it if you have any experience with it. You need to rotate the secret, you need to change the references, you need to rewrite the history, you need to make sure all the SHAs are updated, and anything that uses those git commit SHAs in the downstream systems, you need to update those too. So it's not easy, right? The next one is pre-receive hook, right? This is this is a place where we can actually block the secrets from getting into Git history. So the advantage is that this is centrally configured, right? And it gives us the best opportunity to roll out changes to the entire company in one shot. Here is where we can say we can create all sorts of rules that an enterprise needs to say we want to block secrets of certain kind, like AWS keys or GCP keys, for example, or anything like that. And we can have rules such as some are warning only, some are errors, right? And the further you go to the left, obviously leftmost is the best places to intercept, but it comes with a challenge, right? It provides the least amount of effort to reverse an incident, but it also comes with a bunch of operational burden, right? Whatever tools we use for this, we need to ensure that we distribute these tools to all the developer laptops. Like NM has like 4,000 developers, and imagine deploying something to all of their laptops and ensuring that accuracy, the version are accurate and all of that, right? Ensuring everybody uses those. It's a lot more operational burden there. So essentially a pre-commit hook, if you do that, this is essentially what a developer would see. They would make a commit, and the changes it's possible to give them the right level of feedback too, right? Like warning them right away about a specific issue. So essentially the commit doesn't go through. Now there are a lot of open source tools that are out in the market, and to prevent committing a secret into Git or any other tools like that. But we didn't do that. Like we created our own tool, right? There a lot of reasoning behind that was that a lot of these tools were, scanning for a set of regular expressions and like at a high level, right? Or scanning for high entropy strings, right? Which creates a lot of false positives, right? None of them do any validation of secrets. What happens as a result is like you're inundated, your security team is inundated with a lot of secrets, and they have to manually parse through false positives. It creates a lot of burden operationally. So what we have done, the real key here is we have done something to validate those secrets, things such as AWS keys, right? Cloud keys, GCP keys, they can actually be validated. Like you can make an API call, you can make an STS call for AWS, for example, to ensure that the secret is valid, right? So that basically eliminates completely the false positives that you might have. So there's like I said, there's benefits for using some of these open source tools. They give you some value, but really we had some needs that were fairly custom, and we needed to create a workflow of that as well. This is a white paper I highly recommend, that we have used a lot of this content to create some of our own tooling here. So that is essentially all I have for the content. It's open for any Q&A here.
Well, Robbie, this was very good. I appreciate you doing this. Any questions from the group?
I'll just say that I know that, Robbie and I worked together a while back when I was at GitLab, but, it's something that I've seen a lot of companies struggle with these things. And really, to be honest, Northwestern Mutual has been one of the best ones I've seen actually put it in action and make it stick and work for an organization. So especially their size and scale. So Ravi, you've always done a great job with that. Thank you.
Yeah, thank you, John. And GitLab has been a phenomenal partner. I know you don't work for GitLab anymore, but GitLab has been a phenomenal partner with this. Other thoughts, guys? Any other questions, feedback?
Thanks, Ravi. Thank you so much for sharing some insights about this. I learned actually something new today, so thank you so much.
Okay, yeah, you're welcome, Ramesh. Thanks for joining. Let's see the chat. Haven't Lockheed cyber kill chain. I haven't, Morgan. I don't know. I don't know if you can throw some insight on that, but I will definitely look it up after this.
while you guys are thinking of more questions for Ravi, what other topics would you like to see the DevOps meetup do? Anything come to mind?
Any?
I'm just being quiet because I'm new here.
What's that?
I said I'm just being quiet because I'm new here.
Well, hey, Robbie, let me go ahead and stop the recording, and then maybe some folks will want to ask some questions not being recorded. But Robbie, I wanted to say thank you very much for putting this together. It was really, really good and insightful, and it was good to see your organization and how they're advancing and maturing their DevOps strategy.
Yeah, thank you, James. Thanks everybody for joining.